talking about today? Well, we're doing a bit of a triple act here today. That's why there's so many speakers, because we not only want to tell you about our renal model, which is something that we've been building together, but we also wanted to give you a bit of an idea of our experience of going from commercial to open source software or freely available software to build our simulation models. We'll talk about the model first, give you a bit of an idea of what it's about and what we've been trying to achieve with it, and then myself and Yuen will go into a little bit of our experience on that end, because it was quite new to us. This time last year we had not built an open source model, and now we're sitting here with one. And yeah, it's been a roller coaster, but I feel like it was a really good journey, and I would encourage people to try and do open source modeling just generally as well. Okay, so let's dive in. So what are we talking about today? Well, the model we're talking about is a hybrid model, which is actually a combination of two different types of simulation methodology. And what we're trying to do with that model is investigate interventions for renal care, and specifically looking at interventions that could impact on the capacity for in-center hemodialysis or dialysis pathways just generally, or kidney replacement therapy pathways generally in the future. So the background was that we were approached by Midlands Renal Operational Delivery Network. They were concerned about the predictions around future capacity for dialysis, specifically with that in-center dialysis, because they basically said, well, if it grows at that rate, we're going to have to build new facilities, etc. We've not got the capacity to actually serve that many people under our current infrastructure. And we're also interested in how the population is going to change. We're interested in how we can actually impact that capacity. So how can we actually do that? And it felt like a model was a natural way to do that. It provides a risk-free environment to allow us to play out different interventions. So we were brought in to try with that. So the objectives of the modelling, we're looking at, can we predict how demand is going to change over time across the renal pathway? What does that mean for capacity of renal services? And can we make a difference? So can we do some scenario modelling to look at upstream, so maybe preventative type actions before people come into the kidney replacement therapy system, and downstream in the kidney replacement therapy system to make a difference as to where people are being treated, and can that take some relief from those future predictions of what's going to happen. Okay, so at a high level, our approach to doing this whole project has been very participative. And what I mean by that is that we have brought along the clinicians and nurses, a range of different voices, patients' voices even, have been kind of brought along the journey of making this model. And why did we do that? Well, we want them to have ownership of the model. We want them to see their experience reflected within the model, to enable them to trust it, to then, see the predictions that it gives, and the estimates that it provides, and actually trust that they're accurate estimates of what's actually going to happen. Because I feel like half of the battle in modelling is not the actual model building itself. It's then taking your results of your modelling to your client and saying, this is what we have estimated is going to happen as a baseline, and this is what we've estimated is going to happen under intervention A, B, C. Because if they've not got trust in the model and they don't align themselves with it, then they're not going to be able to kind of trust that journey. So that's really important. So this model has been built in participation with a range of different voices, and they were involved in different workshops throughout the model build, including mapping and validation, until we got to a finished model. And the output of the modelling so far has been a system dynamics model that represents chronic kidney disease progression. I'm going to hand over to Sally in a second to take us through that. And then following that, a discrete event simulation model that looks at individual patient pathways or their individual movements through kidney replacement therapy. So what do these two combination of models give us? They're giving us an environment to play out interventions in a risk-free way, and produce defensible evidence to, for the different interventions that could then be potentially written up in business cases to support actually making those changes. So it's all about evidence-driven decision-making, effectively simulation. So, and this is kind of a kind of zoomed out picture of the whole model that we've built. So there's two components to it: a system dynamics model here, which again Sally will talk about, but they are connected by the projection that the chronic kidney disease model gives us for how many people are going to be coming into kidney replacement therapy over time. And then that incidence profile basically pushes patients into discrete event simulation of people's pathways through chronic kidney replacement therapy. So where they are on dialysis or whether they're living with transplant, etc., out into the future. So the two components on their own are actually quite simple, and they come together very powerfully to give this full view of renal care, at which we can play scenarios out upstream or downstream to consider their impact. Okay, so I'll pass over to Sally now quickly. So she's going to take over. I'm going to stop sharing. Is that right, Sally? Or do you want me to just click you through?
Just carry on. Yeah, it's easier. Okay. So chronic kidney disease, we decided to model this at a population level for a number of reasons, partly because it is, we start off with the whole population and then it kind of filters down and gets very small numbers at the end. And there's also a lot of gaps in the data that we know within the middle of the system. So system dynamics, it deals with kind of averages rather than individual people and entities within the model. So it's an appropriate modeling method to use for this. So within the pathway, chronic kidney disease is a staged disease, and stage 1 and 2, and also kind of 3 to some extent, are often symptomless. So there's people sitting out there in the population not knowing that they have it. So we started modelling this from stage 3. So Lucy, if you just advance on a bit. So people will join this system coming in undiagnosed stage 3. There we go. And then most diagnosis occurs at stage 3. So you could drop down to the diagnosed stages in the bottom row. However, some people will remain undiagnosed while their disease worsens. And then once you have been diagnosed, management of the disease can slow your progression and also possibly slow your mortality or reduce the mortality of that. And then a small number of people disease will progress to the point where they need kidney replacement therapy. So that was the pathway that we modelled. If then move it on to the next one, please. Thanks, Lucy. So within the workshops, there were 3 intervention areas that were identified. The first one was primary prevention strategies that reduce the incidence in the first place. So we're reducing the number of people entering the system. And we needed to try and incorporate that into the model, but keep it very broad rather than specific, because people talk about exercise, smoking cessation, but we needed to keep it broad. The next intervention was increased diagnosis. So we currently do not diagnose at the rates that NICE guidelines suggest we should be. So if we could increase that, how would that change the prevalence of people with the disease? And then the big one was the use of what within the model we call advanced medications. So these are things like SGLT2 inhibitors, that they reduce progression and reduce mortality. So we want to see how increased use of these medications will affect both the prevalence of people with CKD and also the number of people that will then kind of flow through to need kidney replacement therapy. And it was also recognised that due to the comorbidities of CKD, there will be people undiagnosed who will also be in receipt of SGLT2 medication, predominantly through diabetes and things. So there is a function within the model that you can apply medications to the undiagnosed stocks, bearing in mind that there's kind of uncertainty around that. So we built the model using proprietary software, so Stella Architect, but we've hosted it on a publicly available website. So anyone can get to it using the link. And then I'm not going to do a full demo with you, but I'll just very quickly show you what the kind of things that we can do with it. So here we have charts that kind of mimic that pathway. So undiagnosed prevalence charts, so undiagnosed in the top row, and then you drop down to diagnosed. And as you move right across it, and then people are worsening in their disease stages. We start off with the baseline, which is if we do nothing different, what will prevalence look like running from now up to 2030, end of 2035. But then what we can do is apply some changes here. So in the demo I'm showing you just now, we're applying the changes from the start of 2025, but there is the ability to stage it, to step it, to apply a small change, run it for a year or 5 years, apply another change and keep running it through that way. So I'm just going to show you what happens if we increase the reach of SGLT2 inhibitors. Through the workshops, there was a desire to kind of get to 80%. So 80% of people with diagnosed CKD being prescribed SGLT2s. And we can see what that does to the prevalence at the different stages. So if we think SGLT2s reduce progression, so we're kind of keeping people buffered up at the stage 3 and a reduction in the more advanced stages. So that's kind of what we'd expect. Up here, total prevalence, we've got slightly, I know it's probably a bit small to see on this, but we've got slightly higher total overall prevalence with the scenario than the baseline. And then we also added in a cost element to it. So again, it's difficult to see because they're quite close together, but giving out more medications actually increases cost. Because you're giving more medications to more of the population, but you're reducing the number of people with on the KRT. So it's being used, for a variety of different types of people for different reasons. But we've got that flexibility to kind of play out these different scenarios. To link it in with the KRT model, you can run a scenario and then export the incidence into KRT. So export a table there, which just downloads to your computer, and then you can import it into Lucy's aspects of the model. And I think Lucy's put the link in the chat, and then we'll share it out with the slides or something afterwards. So do please go and have a play with that. Over to you, Lucy.
Look at that seamless transition there. So one thing I should say actually is the comment there on the costs being higher. It's because that is a very expensive drug currently, but we've just heard that it's coming off patent, so that might actually change the full picture of that, which is really good news as well. Just going forward for people living with type 2 diabetes / CKD. So anyway, I'm going to talk about the second aspect of the model, which is looking at the kidney replacement therapy system. And we've been modelling that using discrete event simulation. So where the system dynamics part of the model, that methodology really, it looks at the flow of patients or the flow of a population through a system. It doesn't really focus down on individual people, but it's more of about the natural progression of something. So it really fits with things like diseases and chronic diseases in particular, because they're about people's deterioration over time, whereas when we're thinking about people moving through a pathway, and discrete event simulation seems to work really well for that, because it's about looking at how people, where they are in a system at a specific time, and when their next event is, i.e. when they're going to change to maybe change to a different dialysis modality, or when does that donor organ arrive that they can then have a transplant with, for example. So really, the reason we split the model in this way is because the two methodologies kind of speak to the two different actual physical processes that we're trying to model. So yeah, we're looking at discrete event simulation for the pathway modeling, and this is a high level diagram zoomed in one from before of what we were doing here. So what we were assuming was we're taking our incidence of people arriving to the kidney replacement therapy kind of pool of patients from the CKD model, because that's what it projects out. And we then, for different patients that arrive, we give them attributes like age and referral status, and that governs how they move through the model, whether they're diverted to conservative care, for example, i.e. They're diverted before having any treatment, whether they're suitable for transplant, and whether they receive one before having any dialysis. They can move straight to dialysis, and they're allocated to a specific modality, which could be in-centre hemodialysis, home hemodialysis, or peritoneal dialysis. So these are 3 types of main dialysis that we've considered in the model. And they can live with, after having a transplant activity, they can live with it for a certain amount of time before graft failure or death. And they can leave any of the different areas of the model to die, basically, at any point. So this model is underpinned by UK renal registry data. They provide us with a data extract of basically at patient level of how people, it was anonymised, but at patient level, basically where people were in the system from 2010 to 2022. And from that, we were able to build distributions for how many people were suitable for transplant given their age and referral status, etc., and how many people had preemptive transplant of those, etc. So we were able to build models that then go into this system and basically govern the way people move around it. Okay, and then we look at how they perform in the years outside of 2022 onwards to see how well we're matching the behaviour to get that validation. So where the CKD part of the model was at population level, and we did that at national and regional level, and it made sense to do that because we were looking at quite large populations and there was data limitations there. We had a lot of data here, so we could build down to national, regional and centre level. So for each centre in England, we could build a centre level model of what their renal capacity or kidney replacement therapy capacity is going to look like in the future. The planned interventions that we're interested in within this system. So we're interested in all the upstream interventions that Sally's mentioned, because they will have an impact on how people are flowing into the model. So we can do those types of interventions, but we can also directly impact how people are flowing around this model. So we could look at if we put them on home therapies more often, if we increase their diversion to conservative care, if we increase the number of live or cadaver donor transplants. We were interested specifically in live initially because of different initiatives that have been done in the UK where they've actually been able to boost their live donor transplant through talking to families. We could look at whether we could work people up quicker so that they were more likely to have a preemptive transplant rather than going on dialysis first. And we also were interested in what if we could actually improve the health status of people arriving at the model, so that because people with late referral status actually have poorer health outcomes within the pathway. So those are the different interventions we were considering, as well as validating for the different centres how they were kind of performing over the years after fitting the model. We also looked at against external models, how are our models looking? So you can see there's 2 different predictions here from our 2 different models. So the discrete event simulation was providing this blue for the Midlands region, the prevalence of what was going to happen out to 2035, and the red is the system dynamics prediction. So you can see that they aren't giving exactly matched predictions of what's going on. That's because they're coming from 2 different methodologies, but they're within 5% of each other across all different time points. And we know at the start of 2022 exactly what's happened in the data. So we're starting from a known point in time of how many people were in the kidney replacement therapy system within the Midlands. So we know at least this data point was correct. These other models seem to give kind of a similar projection in terms of the increase in the gradient of their prediction of prevalence, but this one from Impact CKD is starting from a much higher entry point, and the Inside CKD is starting from slightly higher entry point and actually predicting still an increase, but a slightly lower gradient. But this, in comparison to other models, shows you where we are in terms of our prediction of what's going to happen. So we're kind of lying between the two other comparative predictive models that have been put out. Okay, I just wanted to it wouldn't be a simulation presentation without showing you the output of some of the scenarios that we could run. So I'm going to start off by showing you one scenario that we've run that's within the kidney replacement therapy system. So this was, if we could, this is specifically to Birmingham Kidney Centre or Kidney Unit. We looked at the baseline of what their activity was going to look like out from to 2035, and then we ran a secondary scenario where we said we were going to raise their allocation probability to peritoneal dialysis, from 25% up to 50%. So the way we did that was we looked at people that were coming into the kidney replacement therapy system. The majority of them were actually being allocated initially to in-centre hemodialysis, and so we took from that in-centre hemodialysis stock, and we kind of population, and we moved people across onto peritoneal dialysis, so they had a higher probability of being allocated to peritoneal dialysis initial replacement therapy. And you can see what this does to it's showing sensible changes. So from 2025, when the change is implemented, the behaviour is exactly the same to that point, but then they start to split. And what we see is people moving off in-centre hemodialysis, which we'd expect. We also see people moving into peritoneal dialysis, which again is what we've actually enforced. So it's again what we would expect. Something we were we think makes sense, but isn't necessarily intuitive, is that we also see a drop in people coming to home hemodialysis, but that's because when people are on one type of dialysis, like peritoneal dialysis, it's much harder to switch them from peritoneal dialysis to home hemodialysis than it is to switch them from peritoneal dialysis to in-centre hemodialysis. So actually, inadvertently, we were moving people a little bit away from the other home dialysis modality. Well, also interesting, we see a little rise in the number of people living with transplant, and we think that was to do with how people move out of peritoneal dialysis into different transplant activities. Okay, right. I'm going to just show one other experiment, and I think this is kind of showing the reason we built the hybrid model was to be able to do upstream intervention and push that information through into the downstream kidney replacement therapy model. So this is about a cross-model experimentation and the impact of increased rollout of SGLT2 inhibitor medication. So basically what Sally showed you previously when she was demoing in the CKD app was that this kind of scenario, but we've gone a bit bloopy to present her, and she's actually passed me an instance profile prior to this presentation, so that we didn't have to do a live demo. But here effectively we're looking at a scenario where 80% of the eligible population are able to access SGLT2 medication by 2030. So there's a nice kind of linear uptake. So it's not just a step change at 2030 up to 80%. There's a nice uptake, gradual uptake of the medication over time. And then the CKD model was run to produce that scenario and to produce an incidence profile. And then I plugged that into the kidney replacement therapy model, and we had a look at what that did. So the output of that is this. So that we're still looking at Birmingham here. So the baseline has not changed from that prior scenario that I just showed you. But you can see that the impact is actually quite large. I mean, we're seeing impact across the board for all the different modalities here. So the total prevalence is much lower under the intervention scenario than the baseline scenario, because effectively, if you stop people flowing into a system, you're going to lower your prevalence over time. You're effectively removing them from this system. And it has a really large impact on in-centre hemodialysis capacity. The same across the board effectively. But here, I think this is the most notable because this is where we were worried about capacity becoming a problem. Okay, so that just kind of shows you that there's a really nice way of being able to look at those upstream preventative measures in and their knock-on effect on these patients that have a chronic condition and then have like a higher hospital need at the end of their life. Okay, so now we're kind of going to move on to talking a little bit about our experience of open sourcing the discrete event simulation model. So myself and Yuen are going to talk about this because I'll talk to you about why I brought Yuen in now as well. So why did we end up in this position where we had a model in commercial software that we then wanted to change into being able to do open sourcing? And I should be clear, I've always been interested in trying to do open source modeling. So it wasn't like this came out of the blue of like, oh no, I'm going to have to do open source modeling. This is something that I had wanted to, we had long-term ambition to do this anyway, but what we wanted to do was for the model that we'd built, it was starting to be used across a number of centres, and we wanted to be able to actually pass them the model to do scenarios themselves and really kind of take hold of the model and the experiments they were doing, because really we're a small team and the number of people doing experiments was, it was going to be starting to get quite big. So we wanted to be able to share the model, but it wasn't possible within the limits of the commercial software we'd built, the way we had. So we basically panicked, had a little like, what are we going to do? And then, well, that was me, like getting worried that I wasn't be able to meet the client's expectations. And then I was like, right, calm down. Let's look at different open source simulation packages and software. And I saw that SimPy was one of the options for that. So I went to our data science team, and Yuen partnered with me to kind of look at options, and we chose SimPy to use, mostly because we both got a bit of Python experience, so it was a language we already knew, and because of its flexibility. And there's so many helpful resources out there. So if you are looking at wanting to do a start into simulation or a start into open source modelling, I would really recommend the resources available from HSMA, which is the Health Service Modelling Associates Programme. They've got this little book of DES. They've got a really intuitive app called the Simulation Playground, which can help you to learn like the whys of what we're doing in discrete event simulation rather than just be thrown in and try and build one. So I would recommend that as well. Just go and have a look at their resources. I'm happy to share some of those afterwards. But that was kind of why we kind of went down this route. And then we had to apply for internal funding because we didn't want our client to bear the brunt of, having to rebuild this model again. So we did internal funding for it, and we were backed by our organisation because the strategy unit is really big on doing open source modelling that's transparent and documented and shareable. So I think there's been lots of benefits to doing that, and we're going to go into that a little bit more now. Okay, so I'm going to hand over to Yuen for a second just to talk about some of the more technical aspects of the project. Do you want me to just click on Yuen?
Yes, please. Thank you. Thanks, Lucy. My name is Yuen. I'm a data scientist at the strategy unit. So just to give some context, I know very little about simulation. So my background is more, it's complicated, but my background is more sort of just in programming and in building natural language processing models, that sort of thing. So when Lucy came to me with this, I was like, I know a little bit about simulation from the HSMA program, but not really that much. I wouldn't feel confident, actually implementing a model, coming up with all the methodology by myself. So I feel like I was more there as a technical advisor. So Lucy was more in charge of the methodology of the simulation, and I was sort of there to help build the code scaffolding, really. And one of the things that we tried to do was to adhere to the reproducible analytical pipelines guidance. So NHS England have published these levels of RAP, which I've linked to in the slides. And so when I say that I was there to provide technical advice, like I sort of, Lucy could have done so much of this by herself. Like she was amazing at coding with Python, but maybe lacked some of the formal frameworks that would go around making a package like easily, openly available and reusable by other people. So there's things that I've put on the screen, like there are in the RAP guidelines, like coding standards. We have tools that make our lives easier. So when you see continuous integration there, what that means is that when we make a change to the code, GitHub automatically runs those checks for us to make sure that we've put our commas all in the right place and the spaces and all that kind of thing. And it runs tests to make sure that the code actually runs from end to end. Documentation is super important as well. And I think something that's not really often shouted about enough as an important part of making code open source. There's no point in sharing your code unless you explain how people can use it as well. So we put in a lot of effort to make sure that the README is good, and we have a wiki as well to answer any questions about the project. So if you're interested in making your code more reproducible, implementing some of this open stuff, we have fortnightly RAP drop-ins, which there's a link to that in the slide. So if you want to come and join us at that, if you've got any questions on how to do this in your own code. And we also have the team behind the HSMA have also made oh God, there's so many acronyms, discrete event simulation, reproducible analytical pipelines book, which they've recently posted about in NHSR Slack. So I think the guidance there is very specific to how to implement RAP in simulation. So that's really helpful as well. So RAP can be used just for your general analysis, but also specifically to simulation. And that's where you can get some of that guidance. Yeah. Can I have the next slide, please? Thank you. So I think really key to how we work openly is that we use GitHub. So you might know about GitHub as just a place to put your code and store it there, but we also find it really helpful for other purposes. So we use it for project management. So if you have a look at our repository, it's open and you can see that we use the issues tab. We add issues every time we want to develop different aspects of the model and introduce new features. If we just have questions or want to have a discussion, we also use the issues. So it's not just the code that's open, but also the way that we work is quite open. And that can be quite like a vulnerable sort of experience, I think, like to make everything so publicly available. We have quality assurance processes. So we have the tests, which is one form of quality assurance, but we also review each other's code before it goes in. So being quite strict about the way that we merge code and make amendments to it, develop it, means that we catch each other's bugs before they go in. It's completely free to our organization. So we use the free version. And that means in some ways, like I think one of the big concerns that we've had when talking to people at other organizations about using GitHub is that how secure it is and whether the data is going to get leaked everywhere. I think making your code open makes you more anxious about what you're sharing and what you're not sharing. So we're really careful that the data is not there. It's only the code that's on GitHub. And you can do that we have like some guidance on our team's GitHub guidelines on how to make sure that you're implementing that best practice on GitHub. So if you're interested in making your code more openly available, we've got some guidelines there to help you with that. Is this me again? Yes, I think it is. All right, so we have some quick wins. So the model's already being used in business cases, which is really awesome to see. Like, it's, there's no point in building these things unless people use them. So the aim was to make it more easily accessible, and that's something that has already happened. We've had people running the code on their own machine. So that's the biggest test often with open source code. Like, does it run on your machine? And it does run on their machines, which is excellent. I think, Lucy, you might want to talk about this, but how the model's been you've had more control over the model compared to using the proprietary software.
Yeah, I guess what I'd say is it's a bit of an like it's an open playing field. So you know, some people might find that overwhelming. They're like, oh, I can make any decision now, but I found it quite good because there was some parts of this like, for example, I wanted to be able to say somebody's living on dialysis, and oh, there's an organ ready for them, and I wanted to pull them out of a process to pass them on to into living in transplant, for example, and I could do that so easily in SimPy, but I had actually really struggled to figure out how to do that physically. It was a real shoehorn in the previous commercial software. So we actually ended up with a less over-engineered model, which to me, less over-engineering with simplicity means less uncertainty that you're sticking in there yourself. So it really spoke to me, that one.
Excellent. And the building ones for potential multiple users, I think, is the idea that the model will be used across the different regions in England. So that's awesome. We don't have to build separate ones for all of them. It's just reusable for different organizations. We did have to make some compromises on the way, though. So Excel is not great as an input and output. I think it's, it is proprietary, Microsoft Excel, and there's so much scope for error. It just needs someone to accidentally press a button on a keyboard to change the inputs in Excel. So that's not the most reproducible part of our model, I would say, but we just didn't have the time really to do that. Although we have said that people are running the code with minimal support, there is still support required. So some of the users of the model don't have experience in using Python at all, or the terminal, or the, just code awareness. So it can be difficult for them. So there is still, like, the barrier to entry is still relatively high. I think you have to know a little bit about using code and like cloning the code from GitHub and that sort of thing. And also a consequence of not having as much time as we would like. I mean, how long? Yeah, there always could be more time to work on things, but we've still got some testing coverage. It's not 100%, for example, and there are other developments that we'd like to make, but we were limited in the time and funding that we had.
Thanks, Yuan. Yeah, I think that was a really good summary. I think the only thing I'd add to, I probably should have said this on the first slide, one benefit that we had in actually choosing this model as something to go and open source was that we already knew the system really well. So actually we had, there is a benefit of actually building something initially and then turning it to open source. So if you are actually thinking about doing your first open source challenge, then potentially working on something that you know either well because you're working in the system, or that you've previously built as a simulation, I think was a head start because there was less of a learning curve. I was learning SimPy, I wasn't learning about renal systems. Anyway, so what's next for us? Well, where the funding would allow us, we'd like to actually continue to keep working with this model. It feels like there's still quite a lot of additional areas where it could benefit us. So we are interested in terms of open sourcing to add the code to Atlas, which is a directory of open source tools and packages. So if we want to kind of give that a little shout out here, because if you haven't seen many open source simulation models, then Atlas is a really good place to start as a place to look, because they rate them in terms of how well they're produced, in terms of like a gold, silver, bronze system. So you can start to look at a few really good use cases that have done it really well. And we're aiming to kind of submit ours and just first time get a gold, maybe. I don't know. We'll just have to see what happens. We're going to also in the future, at the moment, to connect the two different models, so the CKD and the KRT component, you have to manually export an instance profile from CKD and then put that into a place in the KRT model interface, which it's very simple to do, but it would be so nice if they were seamless. So it would probably cost us quite a bit to actually do this step. So I don't know where I see this happening in the future, but ideally in the perfect world, we would seamlessly connect them. And also the CKD model is currently, it's actually transferable into Python. So it is a possibility to do that. We are currently rolling this out. So we started in the Midlands, we're rolling this out in London at the moment. and in the east of England, but we are really hoping to take this to be a national model that's something that provides like a consistent comparator to either local ways of forecasting kidney demand, or becomes kind of like the consistently used planning tool for planning, strategically what's going to happen in kidney replacement therapy. But we're working with individual units, etc., to do that at the moment. So we're really, I'd still say baby steps we're taking towards that, but we have spoken to UK Kidney Association and the UK Renal Registry, and they are interested in hosting the model and letting us hand it over to them in a few years' time. So to have their backing actually feels like a really big step in the modelling, because they're already saying, yes, you're doing a good job and we can see that it's making an impact already and we want to spread that. Okay, so yeah, we'll leave it there in terms of the content, but we would like to thank network manager from the Midlands Kidney Network, Marie, and anyone that's taken part in the group activity for building the model, the UK Renal Registry for supplying the data. Should also say the patients, because they were also involved in a patient workshop, and we had some external academic advisors on this project as well. If you are interested in looking at either of the GitHub repository for the KRT model is here, which you can just get your phone and take the link there. I've already put the link in the chat for the CKD progression model, but you can also do the QR code for that as well. And we'd open the floor to some questions.
Thank you, Lucy, Ewan and Sally. Thanks ever so much for that. That's a really interesting walk through this work that you've been doing. Some really excellent work. And I think we've got a blog on it as well. I think we're trying to share what our approach to it and to make sure others are able to learn from it. I'm not getting any non-verbal clues because I can't actually see your cameras. There's something wrong with my system today, but not to worry. We do have lots of questions. So what I'll do, if that's okay with you, I'll share my screen, my Slido screen, and we can maybe pick off one or two of those.
Sounds good.
Okay, so if it's okay, I'll read them, and I think we've got time to cover them off. So I'll start with Douglas's point at the bottom, because that was made during the presentation. So this was about the cost of being higher is also because the prevalence goes up, meaning that more people live longer. So it's a good thing.
Can I save some time, because I think that Lucy answered that question in her presentation as it happened. So I'm happy to let other people have the floor.
Okay, it's good to see you, Douglas. Although I can't see you, like I say, I can't see anyone, but that's it's good to see.
Thanks for coming, Douglas.
Hi. Yeah, so there's a couple more points. So this again, the second question here or comment. What advice? So we talked about this a little bit, didn't we, Lucy, at the beginning? So what advice would you give to others who might want to do something similar? How do you start with this, if this is kind of brand new to you, but they've been inspired by what they've seen today?
I would say it was, I really benefited from having UN work alongside me, who had that kind of technical, package building, repository building, open source knowledge. Without that, I think I would have taken a lot longer to get to where I am, and also probably the result wouldn't have been so polished. So, but I think that if I was coming at it again, and I was like looking in hindsight with rose tinted goggles maybe, but I would definitely be looking at some of the examples of other open source repositories to try and get motivation from those. So, if you want to have a look at ours, please do, but also look at those on Atlas. And as I said earlier, kind of alluded to, that we're trying to set up a modelling club that might start to kind of, like a book club, look at models and how they're reproducible, what they do well, what they don't do so well, so we can all learn together. So hopefully in the future that'll be coming down the line with some of the people from HSMA involved also. When did you want to come in on that as well?
Yeah, I think the DES RAP book has got like really step-by-step guidance and exercises as well. So I would start there, maybe, like it's really structured for beginners as well. So I would, if you didn't have any support available to you and wanted to teach yourself, there are resources online to help you with that.
Yeah, so if you don't have a Ewan out there who can help you through this, there are some very helpful resources. Very aware that some people can't see the chat. I will share everything that's been mentioned after today's session, and some of it is linked in the slides as well. So thank you very much for that. I think we've got time for just a couple more questions. So another question here is, okay, so did you find that you could explain the modelling to non-analysts and people who had no experience of this type of modelling? Is it a good way to explain something to others? Did you bring them on this journey together, or how did you approach that, Lucy?
So I think this was actually, because I joined the project late, this was actually not, I wouldn't say this was my inspired idea to do this. This is actually more to do with what like Sally and Jen and people that were, and Stacey, who were initially involved in it. But that participative modelling bit, I think, was invaluable. So by getting people in the room and mapping the pathway together, getting them to understand at the beginning, like, this is your system, we've understood it, like that was invaluable. And I feel like that's changed our approach to all the projects we're kind of currently looking at in the future. Sally, you're much more able to speak on that. So
well, no, I just not to say anything different about that. So there's two aspects to this. One is the people that were involved with us at the model build, and so that, there's a lot of work goes into those workshops explaining the kind of the background to these methodologies. But the second bit is, now that we're rolling these models out, these new people that we're presenting it to they're just getting told about it. So they haven't come on that journey. So again, we have to, within an hour or an hour and a half of a demonstration time, we have to, bring that gentle introduction to what the method is.
Yeah.
To then go into the detail of it. So yeah, and there's a balance in it between having too much. I don't show the back end of the system dynamics model because it would frighten you to look at it from a standing start. But you want to have a little bit of knowledge about it, so it's not completely black box. So it's just developing some kind of methods that are just gentle introductions generally, and then into the detail of what this actual model is.
Yeah, it's interesting. We keep seeing those little barriers as we're going along, where we're like, oh, we got to tell somebody else about this. And I do feel like the pathway to impact for a model like this, you think you've cracked it, and then there's maybe something else you've got to kind of overcome. So I think somebody explained it to me recently as like firing an arrow through a piece of Swiss cheese. Like, there's always like you can sometimes get through one hole and then maybe another, but then there's always like a little bit more cheese. So it just feels like that kind of thing where we are getting there, but it is slowly. So there's lots of that, trying to bring non-modelers on the journey.
And it does. I mean, obviously, it's incredibly important to get them there at the beginning, so that it's an accurate reflection of those healthcare pathways for the credibility of it. But so that they can have that input. But yeah, it doesn't stop there. You have to keep communicating to people about the model and why it's for them to believe it and for them to be able to use it as well effectively. You've got time for maybe a couple of questions, but I'll zip through them, and if you've got anything left at the end, I'll share it with you after. So someone has said here, well, maybe we could have a huddle on GitHub. I mean, why not? It's an incredibly useful resource and essential for RAPs, and maybe that's something we have done this in the past actually, so it's something that we can come back to. Now more and more people are sort of using and seeing the value of that and RAP as well. Someone says, so great, you found it possible to rebuild the model in Python. Was this possible for the SDM as well as the DES? And did that need different packages? Are there packages for, this is probably not a very quick question actually, but are there packages for other simulation methods, e.g. ABM? Is there a quick answer to that?
It's a quick answer. I can't answer ABM. System dynamics, there's a package called a agile system, ASDM is a Python package, and we've worked with a developer on that. So we've taken a built model and then rebuilt it using ASDM already. We haven't had time to do this. So for me, I would build my system dynamics model using the proprietary software. But then the interface aspect of it, the delivery aspect of it, we could do in open source. It just needs the funding and the time for that. So yes, it is possible. Our wish is that we get funding to be able to do that, and that's when we can link the two together all seamlessly and build like a Shiny or Streamlit interface for that. So it is possible, and we do have some stuff on our GitHub about that for the prototype one we did. Yes.
It's lovely. Thank you very much. And just very quickly, the last couple of points. So someone is asking, is there a similar model for CVD and cancer? Well, there isn't, but I'm sure there are many healthcare pathways, probably if they're very sort of discrete, where this would work very well for something for the future, something for people who understand those pathways to have a think about. And then our last comment here is about, can they join the RAP? And I think they're not NHS. So I think at the moment, unfortunately, the RAP is only available to NHS. We've had this before, but maybe
just come along. Just come along. Like,
just
come
along.
Come along.
There you go. There you go. You says you can come. You're very welcome. Anyway, we just tipped over to 12 o'clock. So thank you again to Lucy, to Sally, and Ewan for sharing that with us. I've really enjoyed the session, and Douglas as well for coming along and commenting as well. And thank you for everybody who's come to join us today. And I haven't got time to go through what's coming up next, but I might share it in the email after today. And I'll anyway, I will see you in a couple of weeks, and I enjoy the rest of your day. And 2 weeks today, minus 1 hour and a minute, and I'll see you again. Bye bye, everyone.